Mini lesson 2A, complementary, supplementary, and vertical angles. Complementary angles are angles that add up to 90 degrees. Let's look at this first example. We have A and 28 degrees. Let's set those equal to 90 degrees. Subtract 28 from each side. A equals 62 degrees. Let's look at the next example. We have a straight line that measures to 180 degrees, and we have 90 right here. So that means that these two angles also need to add up to 90 degrees. Let's set these equal to 90. Combine like terms. 2A plus 3A is 5A, and negative 2 plus positive 2 is 0, so they cancel. Divide each side by 5. A equals 18. Now, if we want to find the specific angle measurements, we would evaluate each expression where A is equal to 18. We have 34 degrees and 56 degrees. Let's look at this example. They are complementary angles. They add up to 90 degrees. Combine the like terms. 5R plus 7R is 12R, and 7 minus 1 is 6. Subtract the 6 from each side and divide each side by 12. R equals 7. If we want to find the specific angle measurements, evaluate when R is equal to 7. This will give you 42 degrees, and then this one is 48 degrees. Let's look at the next page. Supplementary angles are angles that add up to 180 degrees. Let's set A plus 26 equal to 180. Subtract 26 from each side. A equals 154 degrees. Let's look at the next one. 6z plus 1 plus 77 equals 180. Combine the like terms. 6z plus 78 equals 180. Subtract 78 from each side. 102. Divide each side by 6. Z equals 17. Let's plug it in to get the angle measurement. 103 degrees. This example has a circle with a quadrilateral inside of it. Cyclic tetragons, four-sided polygons inside of a circle, will have opposite angles equal to 180. Since that is the case, we can solve for both x and y by setting them to 180 degrees. 86 plus 5y minus 91 equals 180, and 69 plus x minus 37 also equals 180. Let's solve for these variables. Combine the like terms. Add 5 to each side. Divide by 5. Y equals 37. And let's solve for the other one. Subtract 32 from each side. X equals 148. Let's evaluate these. 148 minus 37, 111 degrees. And then 5 times 37 minus 91. That's going to give us 94. Vertical angles are angles that are equal to one another. If C is equal to this angle, then C also must be 122 degrees. Let's set these equal to each other. 5r plus 8 equals 7r minus 8. Subtract 5r from each side. Add 8 to each side. And divide by 2. R equals 8. Plug it into one of these two to get the angles. We get 48 degrees. Let's solve for the next one. 7t plus 1 equals 8t minus 8. Subtract 7t from each side. Add 8 to each side. 9 equals t. Plug it in to get the angle. 64 degrees. Let's look at the last one. What would be the probability of a spinner landing on either section B or D? Justify your answer with algebraic and verbal steps. All right, first of all, let's solve for what the value of x is. 5x minus 7 equals x plus 85. Subtract x. Add 7. And divide by 4. X equals 23. We'll use that to find the angles. 5 times 23 minus 7, or 23 plus 85. So that's 108 degrees over here and 108 degrees over here. And we know that B and D also have to have the same angle measurements. So we could do 180 minus 108. So this was 72 degrees, and then this one would also be 72 degrees. There's 360 degrees in the full circle. And so to get the probability of B or D, you would add those two together and divide by 360. You can simplify this fraction. Two-fifths. So it's 0.4, 40%, or just two-fifths. Now let's go back through this and write out those verbal steps. All right, so we know that A and C are vertical angles. So set A equal to C, and we're going to assume that they are in degrees. Subtract x from each side, add 7 to each side, divide by 4 on each side, and then once you get the x, evaluate to find A or C. Once you've evaluated, we'll have 180 minus that number, since they're supplementary. A circle is 360 degrees. And so you would add B and D and then divide by 360. And then you could convert it to a decimal, a percentage, and simplify the fraction.